Yeah, good afternoon once again, students. Can you able to see me? Am I audible and visible? Yes. Okay. Fine. So let's start with a new lesson today. So in the last class, we have completed the equilibrium part, right? So try to solve more questions in equilibrium as well as in thermodynamics. Okay. So today we will start with the mole concept and stoichiometry. Okay, so this will come in your some basic concepts of chemistry lesson, which is the very first lesson of your class 11. So you will be studying the small concept and stoichiometry in that part. So let's start with this today. So the first topic that we are going to see is the mole concept and percentage composition. Okay, so in this under this topic, the learning objectives are the mole, definition for mole, Avogadro number and molar mass. And then we will discuss the percentage composition and the calculation of empirical and molecular formula. Okay. So moving on to the first topic, which is mole, Avogadro number and molar mass. Let's talk about the mole first. So why there is a term called mole? Why mole? Can anyone tell me why mole? Why we are using the term mole in chemistry? Why? What is the reason to use that? Any points from Jain Viramnagar side for this question? Okay. So I'll tell you, atoms and molecules, if you take, they are extremely very small in size, right? And their numbers in even a small amount of any substance is really very large. So in case of this water, if you see here, this is the water droplet. And here 1.67 into 10 power 21 water molecules are there in that single water drop, right? So how to find out this? How will you find out each and every number of molecules or the atoms or the number of particles present in each substance? So to deal with such kind of large numbers, scientists have invented the term mole. Okay, so to deal with such large numbers, they have invented the term mole. Okay, so now what is this mole? So it is just a number as dozen, century, and more. So in 1 dozen, there will be 12 particles. Like in case of 1 dozen of banana, we have 12 bananas, right? Century means it is 100. So 1 mole means there will be 6.022 into 10 to the power 23 particles will be there. The particles can be ions, the particle can be atom, it can be a molecule, it can be anything. Okay. So this many number of particle will be present in 1 mole of the substance. Clear? Is this okay? Now we will discuss more on this mole. What is the definition for this mole? The amount of a substance that contains as many particles as there are atoms in exactly 12 gram of the carbon 12 isotope is called as 1 mole. Okay, so we are having 12 gram of carbon 12 isotope. Okay, the number of atoms or the number of the number of carbon atoms present in 12 gram of the carbon 12 isotope is nothing but 1 mole. Okay, so what is the mass of one carbon atom? Any idea? The mass of one carbon atom is 1.992648 into 10 power minus 23 grams. See, it is very small, right? Such a small, very small value. And now coming to the number of carbon atom in 12 gram of carbon, what we have to do? 12 divided by this whole number. And this will give us this Avogadro number, which is 6.022 into 10 to the power 23. Okay. So now this is the mole value. 1 mole is equal to this many particles. Clear? So you have to memorize this Avogadro number, which is very important for you. And the definition for this mole is important for your board exam, school exams. So any doubt from this mole? Definition of mole? No. Okay, now we will move on to entities in mole. So what are the other entities which are present there in mole? Suppose if I take nitrogen molecule, what is the formula for nitrogen molecule? It is N2, right? So in N2, that is for 1 mole of N2, we will have Avogadro number of molecules of N2. So I can represent like this. 1 mole of N2 will have Avogadro number, that is 6.022 into 10 to the power 23 molecules of nitrogen will be present in 1 mole of nitrogen molecule. Okay. If I take carbon, so 1 mole of carbon will have Avogadro number of atoms of carbon. So here it is a molecule and here it is a carbon. Okay. Now if I take any compounds, if I take molecules, okay, like for example, if I take ammonia, that is NH3, 1 mole of ammonia will have Avogadro molecules of NH3. Avogadro molecules of NH3. So if you are taking 1 mole means that is for atom, for molecule, for anything. If you are taking for 1 mole, Avogadro number of particles will be present in that particular system. Clear? Now, with this concept, we will solve one question now. Shall we move on to the question? Any doubt from the mole concept for anyone? So, students who have joined late, we are dealing with the mole concept now. Okay, 1 mole is equal to Avogadro number of particle. So, that is what we have discussed, and we have discussed the definition for mole. Now, we will move on to this question. Yeah, in 3 moles of ethane, calculate the following. First, you have to calculate the number of moles of carbon atom, then the hydrogen atom, and then the number of molecules of ethane. In 3 moles of ethane, we have to find out these 3 things. So, let's start from the first. Okay. So, let's start from the first. So, what is the first question? 1 mole of ethane. First of all, we need to find out the answer for 1 mole of ethane. So, in 1 mole of ethane, what is the formula for ethane? It is C2H6, right? So, the 1 mole of ethane contains how many carbon atom? 2 mole. 2 mole of carbon atom. In the question, they have asked for 3 moles of ethane, right? So, 3 moles means what we have to do? 3 mole of ethane will contain 3 by 1 into 2. Just you cross multiply. You will get the answer. Okay, 6 mole of carbon atoms are present in 3 moles of ethane. Is this clear for all? 3 mole of ethane will contain 6 mole of carbon atom. Shall I move on to the second question? What is the second question? We have to find out the number of hydrogen. Yeah, thank you so much, Ramnagar students, for your response. Now we will move on to the number of hydrogen atoms present in 3 mole of ethane. So 1 mole of ethane contains how many hydrogen? We have 6 mole of hydrogen atom, right? Now for 3 mole of ethane, 6 into 3 by 1. That is 18 mole of hydrogen atom is present in 3 mole of ethane. Okay. Then the last question is we have to find out the number of molecules present in 3 mole of ethane. Number of ethane molecules in 3 moles of ethane. So 1 mole of ethane contains Avogadro number of molecules of ethane. So 3 moles of ethane will have 3 mole of ethane will contain 3 into Avogadro number of molecules, which is equal to 18.066 into 10 power 23 molecules of ethane. Okay. So you need to understand. You need to understand the concept. You need to understand how to find out the given term from the given informations. Okay. Just by memorizing, we will not be able to solve this type of question. You need to understand. Okay, that what is given and what is asked. So accordingly, you have to proceed. So is this clear for everyone? Shall we move on to the next term? Shall we move on to the next term? Yeah. Now, coming to the next topic, which is molar mass. So the definition for molar mass is the mass of 1 mole of a substance in grams is called as molar mass. The mass of 1 mole. Suppose if I am taking H2, to find out the molar mass of H2O, it is 18.02 gram per mole. If I am taking for the other compound like NaCl, then for NaCl, that is sodium chloride, the molar mass is 58.5. So all these are calculated for 1 mole of the substance. If we are having water, for 1 mole of water, How many hydrogen we have? 2 hydrogen. So the atomic mass for hydrogen is 1, and since we have 2 hydrogen, it is 2 into 1, 2. And for 1 oxygen, the atomic mass is 16. So 16 plus 2 is 18. So this 18 is here, molar mass of water. And for the same thing for sodium, the atomic mass of sodium is 23. And for chloride, it is 35.5. So if you add these two, you will get 58.5. Okay. So the mass of 1 mole of the substance in grams is called molar mass. So very easy. Okay. Now we will solve one question. We'll solve one question. You guys are going to give me the answer. Calculate the molar mass of the following. For H2 already we have calculated, no, the molar mass of H2O. So the atomic mass of hydrogen is 1. The atomic mass of oxygen is 16. The atomic mass of carbon is 12. Okay, you need to know these things first, then only you can calculate the molar mass. So now coming to for water, coming to this water, it is 18. We have already calculated. It is 2 into 1 plus 1 into 16. Now, can anyone find out the molar mass of carbon dioxide? What is the molar mass of 1 mole of carbon dioxide? Can you guys try for it? It's very easy, no? Try for carbon dioxide and give me the answer. Very good. It is 44. So 1 into 12 plus 2 into 16, 44. What about for CH4? Very good. Very good. It is 16. 1 into 12 plus 4 into 1, 16. So this is how we are calculating the molar mass. Good, good, Hashira. Good. All of you good. Doing good. Now I will give one more question for you. Calculate the number of oxygen atoms in 4.4 gram of carbon dioxide. Calculate the number of oxygen atoms in 4.4 gram of carbon dioxide. How to solve this? So before solving this question, I would like to give you one relation for number of moles. Number of moles can be calculated using one formula, that is given mass by molar mass. Number of moles is equal to given mass by molar mass. Okay. So using this formula, you can find out the number of moles for a given substance. Now for this carbon dioxide, how to find out the number of moles? It is given mass of carbon dioxide by molar mass of carbon dioxide. The given mass is in question 4.4 gram and the molar mass of carbon dioxide is 44. Just now we have calculated and we are getting 0.1 mole. Okay, 0.1 mole as the number of moles of 4.4 gram of carbon dioxide. Now, so 1 mole of carbon dioxide contains, 1 mole of carbon dioxide contains how many oxygen atom? There are 2. So 2 into Avogadro number of oxygen atom, right? Now, for this given gram, the number of moles is 0.1. So 0.1 mole of carbon dioxide contains how many oxygen atom? 0.1 mole of this carbon dioxide will contain, just cross multiply. Already 2 into Avogadro number is there, into 0.1. Into 0.1. Okay, just cross multiply. You need to cross multiply. You will get the answer. Okay, so what we are getting? We are getting 12.044 into 10 power 22 atoms of oxygen. So these many oxygen atoms are present in 4.4 gram of carbon dioxide. Is this clear for all? Will you all be able to find out the answer for such kind of question? Yes? Very good. Now let's move on to the next topic, percentage composition, empirical formula and molecular formula calculations. Okay. So the first term is percentage composition. Why percentage composition? Why do we need to calculate? So why this term? Suppose if I take a compound, let me take copper sulfate pentahydrate compound. So in this compound, it is a blue colored crystal, okay, hydrated compound. So this compound contains copper, sulfur, oxygen and hydrogen, right? So 4 atoms are there. So what is the percentage of each element present in this compound? Can anyone tell me the percentage composition of these elements present in this particular compound? Just by seeing this compound, we will not be able to tell, right? that copper is present in this much percentage or sulfur is present in this much percentage in this compound. So by seeing this, we will not be able to do that. So to calculate that particular percentage composition of each element, we are using one formula, and using that formula, we can get the answer. So the mass percentage of an element is equal to mass of that element divided by molar mass of the compound into 100. So this formula is very, very important. Now, if I want to find out the percentage of copper, if I want to find out the percentage of copper in the copper sulfate pentahydrate compound, what I have to do? The mass percentage of copper is mass of that element. What is the atomic mass of copper? Atomic mass of copper is 63.5. So for carbon, we are having 12, and for oxygen, we are having 16, and for nitrogen, we are having 14. For hydrogen, it is 1. So like this, for copper, the atomic mass is 63.5. So mass of that element divided by molar mass. How to find out the molar mass? Just now we have seen, no, just sum up all the atomic masses. You will get the molar mass. So if you sum up everything, you will get to 49.5 into 100. So 25.45% of copper is present in this particular compound. And if I want to find out the percentage of sulfur, what I have to do? I have to take the atomic mass of sulfur, right? What is atomic mass of sulfur? It is 32. So how to solve this? To find out the mass percentage of sulfur, 32 divided by the total mass, the molar mass into 100, 12.82. Okay. Now coming to the percentage of oxygen. Percentage of oxygen, what I have to do? So how many oxygen we have? How many oxygen we have in this compound? How many oxygen we have? 4 oxygen here and 5 oxygen here. So totally we have 9 oxygen. So for 1 oxygen, the atomic mass is 60. For 9 oxygen, what is the answer? What is the answer? It is 144, right? So 144 divided by the molar mass into 100. If you're having 2 oxygen atom, then you have to do 16 into 2. Okay, if you're having 3 oxygen in your compound, accordingly you have to do it and get the answer. So the percentage of oxygen present in this whole substance is 57.72. Can anyone give me the percentage of hydrogen present in this compound? How many hydrogen atoms are there in this compound? How many hydrogen? How many hydrogen is there? How many hydrogens are there? Just to see the compound and give me the answer. How many hydrogen we have? 5 into 2. Yeah, very good. 10 hydrogen, right? So for 1 hydrogen, very good, very good. For 1 hydrogen, the atomic mass is 1. For 10, you have to do 1 into 10. So it is 10 by 249.5 into 100%. So 4.01% of hydrogen is present. Got it? So note down this formula and solve the numericals. So now we will see one question based on this mass percentage. Shall I move on to the question? Any doubt from the formula of percentage composition? Will you all be able to find out the percentage of an element present in a compound? Yes. Okay. So then we'll solve one question. Calculate the mass percentage of each element in ammonia. Calculate the mass percentage of each element in ammonia. So what is the formula for ammonia? What is the formula for ammonia? It is NH3, right? So how many elements we are having? We are having nitrogen and we are having hydrogen. 1 nitrogen we have and 3 hydrogen we have. So we have to find out the mass percentage of 1 nitrogen and 3 hydrogen present in this compound. Okay. So for that, what is the formula that we have to use? Mass percentage formula, that is equal to the mass of that element divided by the molar mass. So we need molar mass to solve this question. So what is the molar mass of ammonia? Can anyone give me the molar mass of ammonia? We have 1 nitrogen. So for 1 nitrogen, it is 1 into 14. And for 3 hydrogen, it is 3 into 1. So it is 70. The molar mass of ammonia is 17 gram. Now I have to find out. Very good, Hashira. It is 17. Now I have to find out the mass percentage of nitrogen. The given mass of nitrogen is 14 divided by molar mass is 17 into 100 is giving 82.35. What is the mass percentage of hydrogen? 3 hydrogen I have, no? So it is 3 by 17 into 100, which is equal to 17.65. So nitrogen percentage is very higher than hydrogen percentage. So if I compare the percentage composition of nitrogen and hydrogen using a pie chart, it will look like this, right? 82% is occupied by nitrogen and just only 17 is of hydrogen. Okay. Shall I move on to the next topic? The mole concept and the percentage composition concept, molar mass concept. Is that clear? Any doubt? Okay, good. So now let's move on to empirical formula. So what is meant by empirical formula first of all? Can anyone give me the definition for empirical formula? Have you heard of this term before? Any of you have heard this term before in your school or anywhere else? Have you heard of this? What is empirical formula? Okay, fine. Let's see. So it is the simplest whole number ratio. It is the simplest whole number ratio of various JNV Ramnagar students have already heard of this empirical formula, right? Okay, good, good. It is the simplest whole number ratio of various atoms. Yeah, very good, very good. The smallest whole number ratio. Good, good, you are correct. Of various atoms present in a compound. Okay, we have a compound, and in that compound we may have different kinds of atoms. So the simplest whole number ratio of that particular thing, suppose if I take NH3. Yeah, good, good. Yes, Ashira, you are also doing very great. Good. Your answer is correct. Exactly correct. So if I take this ammonia, now what is the ratio for this nitrogen and hydrogen in ammonia? It is 1:3. They are in the whole number ratio. The simplest whole number ratio of various atoms present in a compound is called as empirical formula. Now coming to the molecular formula, it shows the exact number of different types of atoms. Suppose if in my compound, if I have the formula like this, like C2O4, okay? If I still simplify this, I will get CO2, right? I will get CO2. So this is your empirical formula and this is the molecular formula. So molecular formula is giving us the exact number of atoms or the exact number of different types of atoms present in a molecule, but the empirical formula is giving us the simplest whole number ratio of that atom in a compound. Okay. Now there is one relation between molecular formula and empirical formula. So what is that relation? Molecular formula is equal to N into empirical formula. So what is this N? N is nothing but the molar mass divided by empirical formula mass. This is very important. Okay, N is nothing but the molar mass divided by empirical formula mass. Now, using all these definitions and these formulas, we will find out the empirical formula of a compound from its composition given in the question. Shall we do that? Is this empirical and molecular formula clear to all? Shall we move on to the question? Yes. So here is the question to you. So a compound contains 4.07% of hydrogen and some percentage of carbon and some percentage of chlorine. And the molar mass of this substance is 98.96. What are its empirical and molecular formula? What are its empirical and molecular formula? So to solve this, we can use a tabular method for calculation of empirical formula. Okay, so I'll show you that. This is that table. So the first column is the element, and hydrogen, carbon, and chlorine are the elements given in the question. And next you have to take the percentage composition. of each element given in the question. So I have written all the percentage composition. Now I have to take the molar mass of each atom. The hydrogen molar mass is 1 and for carbon it is 12 and for chlorine it is 35.5 or 35, exactly it is 35.45. Okay, you can take it as 35.5 also. So this is the third column. Then fourth column, we have to find out the percentage, number of moles. We have to find out the number of moles. So what is number of moles? The given mass divided by molar mass, right? So given mass is nothing but the percentage composition. Okay, divided by molar mass will give us the number of moles. So what is the given mass? It is 4.07 for hydrogen and the molar mass of hydrogen is 1.088, right? Just divide these two columns, you will get the answer. So it is coming out to be 4.04. And here 24.27 by 12 will give this value and 71.65 by 35.5 will give 2.02. Okay, so we have found out the number of moles. Then the next job is to find out the simplest ratio or the molar ratio. So how to find out the molar ratio? Divide all the number of moles by the least number. Divide all the H2CCl. Very good, Jamie Ramnagar students, very good. Answer is correct. So divide all the number of moles value by the smallest number. So among these three, the smallest is 2.021, right? So divide all the number of mole by that number. We are getting 2, 1 and 1. So already the molar ratio is in the whole number ratio only. So just take down and write that. So hydrogen 2, for carbon 1 and for chlorine it is 1. We have 2 hydrogen, 1 carbon and 1 chlorine. So the empirical formula is CH2Cl. Empirical formula is CH2Cl. Now, if you see here, we have to find out the molecular formula also, right? We have to find out the molecular formula also. So what was the molecular formula given in the question? Just you see here, the molar mass is 98.96. So N is equal to molar mass. N is equal to molar mass divided by empirical formula mass, right? What is empirical? It is CH2 and Cl. What is empirical formula mass? For 1 carbon it is 12 and for 2 hydrogen it is 2 and for 1 chlorine it is 35.5. So what is the answer? 5 and here 9 and 49.5 is the empirical formula mass of the compound. But the molecular mass, molar mass is 98.96. Empirical formula mass is 49.5. So what I have to do? I am getting just approximately 2 as the value for N. 2 as the value for N. So what we have to do? It is CH2Cl, right? So and here we have N and now the N value is 2. So it is CH2Cl2. This I have 2 carbon, 4 hydrogen and 2 chlorine. So this is the molecular formula of the compound. This is the molecular formula of this compound. Is this clear for all? Will you all calculate the empirical formula and molecular formula? Yeah, good. What is the first step? Write the elements, then write the composition given in the question, write the molar mass, then find number of moles, then the simplest ratio, at last the simplest whole number ratio. Okay, it's very easy. You don't have to worry much about it. Okay, now let me summarize the topics that we have seen so far. Okay, studied the mole and the Avogadro number. What is the value for Avogadro number? Can anyone give me the value of Avogadro number? 6.022 into 10 to the power. How many particle? 10 to the power 23, right? Yeah. Next is, yeah, very good, very good. Yeah, the next is molar mass and the next term is percentage composition, last empirical formula and the very last is molecular formula. And we have studied one relation, right? Molecular formula is equal to N into empirical formula where N is molar mass by empirical formula mass. So these are the topics we have covered so far. Now we will move on to the next topic for today's session, that is balancing stoichiometry and limiting reagent of a chemical equation. Okay. So under this topic, we have stoichiometry and stoichiometric calculation, then limiting reagent. Okay. Let's start with the stoichiometry and stoichiometric calculation. Stoichiometry. So the quantitative analysis of a balanced chemical equation is called as stoichiometry. The study of this is called as stoichiometry. For example, if I take methane, what is the formula for methane? CH4, right? Let me take the combustion of methane. Combustion means 1 mole of methane will react with 2 moles of oxygen and it will produce 1 mole of carbon dioxide and 2 moles of water. So this is the complete combustion of methane molecule. This reaction already we have studied in hydrocarbons lesson and all, no? So the same reaction is this. Now, the stoichiometric observations of this reaction says that 1 mole, in terms of mole I'm saying, okay, 1 mole of methane is reacting with the 2 mole of oxygen to give 1 mole of carbon dioxide and 2 mole of water. Now, in terms of molecule, if I want to express this reaction, I have to say that 1 molecule of methane reacts with 2 molecule of oxygen to give 1 molecule of carbon dioxide and 2 molecule of water. Okay. Now, in terms of gram, if I want to say this, 16 gram of methane, 16 gram of methane would react with 64 gram of oxygen to give 44 gram of carbon dioxide and 2 into 18 gram of water. Okay, so in terms of gram, you have to take the molar mass. You have to take the molar mass. The molar mass of oxygen is 32 because for 1 oxygen it is 16 and we have 2 oxygen atoms. So it will be 16 plus 16. So it is 32 for O2. This is for O2. Okay. Now we have 2 moles of oxygen. So you have to multiply this by 2. We will get 64. Okay. So in terms of gram, you have to take the molar mass. Got it? So any doubt from this? So you need to know how to write the relation in terms, reaction in terms of moles, molecule, and how to express in terms of grams. So any doubt from this part? Any doubt from this part? Shall we move on to one question? Yes. Now let's do one question. Calculate the amount of water produced by the combustion of 48 gram of methane. Amount of water produced by the combustion of 48 gram of methane. So the reaction says that only 16 gram of methane is reacted for 1 mole, right? So we have to find out. Yeah, the balanced chemical equation says that 1 CH4 means it is 16 gram. Okay, 1 mole means it is 16 gram. We have to find for 48 gram. So from this above reaction, 16 gram of methane requires, 16 gram of methane produces 36 gram of water. Because for 1 mole of water, the molecular mass is 18. And 2 moles of water is produced, so it is 36 gram. So 36 is produced. Very good, very good. Now for 48 gram, therefore for 48 gram, 48 by 16 into 36, just cross multiply, you will get 108 gram of water. JNV Ramnagar, you got 96. Did you get 96? 96 is wrong, right? So just cross multiply, you will get 48 into 36 by 60. So the answer is 108. So 108 gram of water is produced from 48 gram of methane. Okay. So, it is 108. I will give you one more option. How many moles of water will be produced if 32 gram of methane reacts? Tell me for 32 gram of methane. How many gram of water will be produced for 32 gram of methane. Instead of 48, if I take 32, what I have to do? It is 32 divided by 16 into 36. Very good. It is 72. It is 72 gram of water produced. Okay. Very good. Good. Now let's solve one more question. Calculate the amount of carbon dioxide that could be produced when 2 mole of carbon is burnt in air. So carbon reacts with oxygen to give carbon dioxide. This is the relation. What we have to do? We have to find out the amount of carbon dioxide that could be produced when 2 mole of carbon. Here only 1 mole of carbon is burned to give 1 mole of carbon dioxide. So now the above reaction says that 1 mole of carbon produces 1 mole of carbon dioxide. In terms of gram, it is 44 gram of carbon dioxide. Right? For 2 mole, therefore 2 mole will produce how many gram? Can you find out? 2 mole means how many gram? It is 88, right? It is 2 into 44. Yeah, very good. So 88 gram of carbon dioxide is produced for 2 mole. If it is 3 mole, 44 into 3. If it is for 4 mole, 44 into 4. So just find out the relation between this carbon and carbon dioxide. So 1 mole of carbon produces 1 mole of carbon dioxide. So 1:1 is the ratio. Okay, 1:1 is the ratio. So accordingly, you proceed. Clear? So this is about the stoichiometric calculation. Now the next topic is limiting reagent. Next we are going to see what is limiting reagent. So what is limiting reagent? The reactant which gets consumed first and limits the amount of product formed. The reactant which gets consumed first and limits or stops. Limits or stops. The stops the amount of product is called as limiting reagent. Or I can tell it in a simpler words, like the one which is present in very lesser amount is called as limiting reagent. The one which is present in very lesser amount in the reactant is called as limiting reagent. Okay, so what are the methods we have to solve problems based on this limiting reagent? The first step is to find out the limiting reagent from the given equation. You have to write the balanced chemical equation first. Okay, then the next step is we have to find out the number of moles. We have to find out the number of moles of each compound. Okay, then calculate the ratio of number of moles to the stoichiometric coefficient. Clear? So these are the 3 steps we have to follow. Write the balanced chemical equation, find out the moles, then find out the ratio of the number of moles to the stoichiometric coefficient. Okay. So the definition for limiting reagent is the compound with the minimum ratio will be the limiting reagent. The compound which is at the limiting ratio is minimum ratio is called as the limiting reagent. Okay, and at last we have to do all calculation based on the availability of limiting reagent. Clear? I told you, no, the one which is present in very lesser amount, that will be your limiting reagent. Okay. Any doubt from the limiting reagent? No doubt? Okay. So next we will move on to the reactions in solution. Reactions in solution. So here we are going to see the introduction to solution, then mass percentage and mole fraction, molarity and molality. So these are the concentration terms that is being used in solutions. Okay. So let's start with the introduction. Introduction to the world of solution. So what are solution? It is a homogeneous mixture of 2 or more substances. It is a homogeneous mixture of 2 or more substances. So a solution may exist in any phase. It can be a cold drinks, and it can be in the form of bronze. It can be in the form of air. Okay, all these 3 contain solution. It may exist in any phase, liquid phase or solid phase or a gaseous phase. In cold drinks, it is in liquid phase. In bronze, it is in solid phase, right? In air, it is in what phase? Gaseous phase. So now coming to the term solute. What is a solute? A substance to be dissolved is called as solute. The substance which is going to get dissolved is called as solute. Now, what is a solvent? What is a solvent? The substance which dissolve other substance is called as solvent. The one which dissolves the other substance is called as a solvent. Okay. Now, solute is usually present in a smaller amount than the solvent. Solute will always be lesser in amount and solvent will be larger in amount, and solute plus solvent will give the solution. Okay. Now, let's see some examples for solution. Let me take ground coffee and water. So, if we mix these two, ground coffee is a solute, water is a solvent, and drinking coffee is a solution. Okay. The next example is salt plus water. So, salt is the solute, water is a solvent, and salty water is the solution. Next, if I take copper sulfate and water, I'm getting copper sulfate solution. Copper sulfate is the solute, which is a salt, water is a solvent, and copper sulfate solution is a solution. Okay. Clear for all? Are very basic and simple terms only, nothing to do much about. Since this is the very first lesson of your class 11, it is very basics are given here. Okay, let me just, I'm just recalling it. That's all. Any doubt you have from this part? Shall we move on to the mass percentage and mole fraction concentration terms? Yes or no? Shall I? Yeah, am I audible? Students? Okay. Others also try to interact. Why you guys are staying silent? Huh? Okay. The next term is mole fraction and mass percentage. So I told you these are the concentration terms. Okay. These are the concentration terms. So I'm having a solution. The quantity of solute present in a given quantity of solution is called as concentration. Concentration is otherwise called as strength. Okay. So this concentration or the strength can be measured in terms of mass percentage, in terms of mole fraction, in terms of molarity, and in terms of molality. Okay. The amount of the solute present in a solution is calculated measured using these four terms. Now coming to the mass percentage, what is mass percentage or what is the formula to find out the mass percent? It's very easy, but you have to memorize the formula. Okay, it is mass of the solute divided by mass of the solution into 100. Mass of the solute by solution into 100. Now I'll give you a question. A solution is prepared by adding 2 gram of substance A to 18 gram of water. Calculate the mass percent. How will you calculate? So what is given in the question? A solution is prepared by adding 2 gram of substance A. So this is the solute. So 2 gram is the mass of solute. Okay, and 18 gram of water means water is a solvent. Yeah, water is a solvent. Then water is a solvent and 18 gram is the mass of solvent. Now we have to find out the mass percent. How to solve this? Mass percent of A is 2 gram and mass of the solution we need, right? Mass of the solution is what? 2 plus 18. 2 plus 18. Mass of A by plus mass of water. It's 2 plus 18 which is giving 20. So mass percentage will be equal to 10%. Good. The next term is mole fraction. So what is mole fraction? The ratio of number of moles of a particular component to the total number of moles. Number of moles of particular component divided by the total number of moles will give us the mole fraction. It is represented by the letter chi. This symbol is called as chi, which we write like X like this. Okay. So the formula is mole fraction is equal to number of moles of component divided by the total number of moles of all component. So suppose if I have two component 1 and component 2. If I have to find out the number of moles of the first component, I have to take, I have to represent the mole fraction as chi, right? I should not represent like this. Sorry for this. Now, if I have to find out the mole fraction of component 1, I have to take the number of moles of that component divided by total number of moles of all component. That is N1 plus N2. If I have to find out X2, When I have to find out the mole fraction of the second component, then the formula will be N2 divided by N1 plus N. Number of moles of that component divided by total number of moles. Okay, it's very easy formula, but very important formula for your 12th, class 12. In class 12 also, you will use this formula very frequently. Okay. So, some more explanation. The formula which I gave you now, that will be explained here. Suppose in this system, I have A as well as B, right? Now, if I have to find out the mole fraction of only the A, I have to do Na by Na plus A. To find out the mole fraction of B, Nb by Na plus A. So, sum of the mole fraction of all components present in the solution is unity. That is, Xa plus Xb is equal to 1. Sum of the mole fraction of all compounds in a solution is equal to 1. Okay. So, with this formula, we will solve one question. If 4 moles of alcohol and 6 moles of water are mixed, then calculate the mole fraction of each component. How to find out? Moles of alcohol is 4 and moles of water is 6. We have to find out the mole fraction using this formula. Can you find out the mole fraction of alcohol first? For 4 moles of alcohol? Can anyone try for it? So, chi of alcohol is equal to Na by Na plus Nw. Alcohol number of mole is 4 and total number of mole is 4 plus 6. 2 by 3. Very good. 6, 0.4. What about the mole fraction of water? How to find out the mole fraction of water? Number of moles of water divided by total number of moles. So, it will be 6 divided by 10. So, that will give 0. Yeah, 6. That will give 0. Now, if you sum up these two, if we sum up these two, what we will get? The chi of alcohol and the chi of water, it is equal to 0.4 plus 0.6. Yeah, it is going to be equal to 1. If you are doing any mistake, just cross check with it. Okay, the sum should be equal to 1. If you're not getting 1, then you have some problem. You have some error in your calculation. You check accordingly and rectify that. Okay, good. Now the next term is molarity. I think we can discuss the molarity and molality in the next class. Is it okay? Will I discuss the molarity and molality in the next class? We can do this molarity and molality in the next class, and then we will try to solve some more previous year's questions of JEE and NEET from this lesson, and then we will move on to the next lesson. Okay. So today we have almost covered all the topics of this lesson from mole concept. Mole concept, stoichiometry calculation, and what is limiting reagent, what is molar mass, and how to find out the empirical formula and molecular formula, and how to find out the concentration terms. So we have 4 concentration terms, and out of 4 we have discussed only 2, and the remaining 2 we will discuss in the next class. Then we will try to solve the problems. Okay. Thank you so much for listening to today's lecture. Meet you all in the next class. Okay. Take care. Bye-bye. If you are having any doubts, just go through the things and bring your doubt tomorrow. We will discuss. Bye-bye. Thank you.